In question 8, we have base 5, base 25, base 125. Now we can't do anything with exponents unless the bases are the same. So what I'm going to do is I'm going to convert that 25 into base 5 number, or 5 squared, and the 125 I'm going to convert that into base 5 as well, which is 5 to the power 3. So I'm going to work this out as 5x minus 2, and this becomes 5 squared to the power x. And so we do the denominator. The denominator becomes 5 to the power 3, 2x minus 3, and then we have this all in terms of base 5. Now I still have to resolve the power to the power issue, so I'm going to keep that separate. This becomes 5 squared to the power x. Well, power to power we can multiply. Here we have 5 power to the power becomes 6x minus 9. So we multiply those powers together, and then we can combine the powers here. So again, this is base 5 on top. We count up the powers. It's going to be x and 2x's, which is 3x's, and minus 2 over 6x minus 9. Now we're going to count the divides against the multiplication, so we could subtract this all, but I'm going to keep this as 5 to the power of, actually I'm going to do something slightly different. I'm going to rewrite this as 1 over 5 to the power 3x, and then I have 2 divides on top, 9 divides, so I could either write that as minus 7 on the bottom as divide, but I could also do it this way. I can count the divide parts as plus 7 on the top, because we have 7 extra divides in the denominator. That means a divide. So I can leave it like that, or I can write this as 5 to the power 7 minus 3x, or I could write this in the denominator as 5 to the power 3x minus 7, and they are all correct.